Hello, we continue our discussion on visualization of hierarchical data. Similar to the previous lecture, our focus will be on hierarchical quantitative data. We will first start by going over a sample data set and tree map, sunburst, and icicle visualizations of it. We will make comprehensive comparisons between these three chart types, and toward the end of the lecture, we will provide some guidelines for choosing the best chart from these three chart types. Now, let's look at a data set that's a bit larger than the example that we showed in the previous lecture. We have a company with 26 employees. Our data contains employee salaries for the company. The company has 4 departments, namely HR, finance, sales, and IT. Each department has employees in different offices. For example, from these 5 HR people, these 2 are from the Los Angeles office. This one works in the DC's office, and these 2 are in the New York's office. We plan to visualize the salaries of all of these employees. The data set that we showed in the previous slide was not hierarchical. We can go ahead and visualize it using a bar chart or a pie chart, but the visualization is going to be cluttered and we cannot easily gain valuable insights from it. What we can do instead is to hierarchize the data according to the departments and office locations. We define levels. Level 0 is going to be the company as a whole. Level 1 is going to be the departments within the company. Level 2 will be office locations, and finally level 3 are individual employees and their quantitative values are their salaries. So this is how we are reorganizing the data. For example, for the finance department, we will have these data. The first column shows the levels in the tree, and note that for internal nodes, the value is the sum of their children's value. For example, the entire department of finance has a salary draw of $220K, or the San Francisco office is costing $120K in terms of the salary of their finance employees. We will put the data for HR, IT, and sales employees in a similar format, and we start visualizing these hierarchical data. Here is the tree map visualization of our hierarchical employee salary data. In addition to the hierarchy that we are visualizing with nested rectangles, we are encoding salary numbers using the area of each rectangle, and we are encoding the department category data using colors assigned to each department. We can make so many observations here. For example, a quick part-to-whole comparison shows that the finance department is the largest department in terms of salary draw from the company. We can quickly see that this is more than 25% and less than 50% of the company's salary expenditure. Also, we can see that the sales department is the smallest in terms of the total salary of their employees. Another observation is that those who work in the New York office, they have higher salaries. For example, these 2 employees, this employee, this one, and this one. We can also see that, for example, these 2 employees have the lowest salaries, and they are both in the finance department and both are working in the New Jersey office. And we can see that the highest salaries are for these 2 employees, and they are both working in the IT department from the New York office. And many other observations could be made. Note that in most implementations of tree maps, the rectangles are sorted with the largest rectangle positioned in the top left corner and the smallest rectangle in the bottom right corner. And this really helps when we are looking for largest or smallest categories. Another point that I want to make here is that tree maps use efficient use of the space. As you can see here, the space is shared between the root, the internal nodes, and the leaves. And this helps with making part-to-whole comparisons. And here is the sunburst visualization of our hierarchical employee salary data. The root node representing the whole company is at the center with child nodes expanding outwards. Each ring around the center represents a level in the hierarchy, and its angle or arc length is proportional to its quantitative value. Leaves are located on the outermost ring, and each segment on it represents an employee. Same observations as those with tree maps can be made. For example, the finance department is the biggest department, the sales department is the smallest in terms of total salary draw of their employees. IT employees tend to have higher salaries. New York-based employees, like these two, this one, and these two, tend to have higher salaries, so on and so forth. We can tell that part-to-whole relationships are not as easy to perceive as they were in the tree map for two possible reasons. Number one, we are dealing with curves and angles rather than straight lines and rectangles. And number two, we no longer have shared space between the root node, internal nodes, and leaves to be able to quickly perform part-to-whole comparisons. Another thing that's missing here is the sorted arrangement of the categories in the tree map. On the plus side, since each internal node has its independent space, the hierarchy is easier to perceive in the sunburst chart. In tree maps, audience can lose the categories in the middle of the hierarchy. Furthermore, nodes further out in the hierarchy may be larger than inner nodes, despite representing a smaller population. This is an advantage of the radial layout in sunburst chart, which leads to the increased area to display nodes at deeper levels of the hierarchy. For example, this leaf node has more space than its parent node, and that's interesting. And lastly, this is the icicle visualization of the employee salary data. As you can see, the icicle chart is structured similarly to the sunburst chart. It displays the hierarchical structure through the adjacency of nodes vertically downwards, with the root here representing the entire company at the top, children nodes here, the 4 departments below it, office level of data below the department level, and leaf nodes representing the employees and their salaries at the very bottom. Note that the width of each node is relative to the salary data associated with it. So the width of the root node is the width of the entire chart. Again, we can make so many observations. Part-to-whole relationships are probably easier to perceive comparing to sunburst charts, but more difficult than tree maps. Here we are dealing with straight lines, and we can just look at the width of each rectangle, or we can look at the area. Since all rectangles have the same height, it doesn't matter how we do the comparisons. Nevertheless, making part-to-whole comparisons is easier than sunburst charts. For visualization of the hierarchy and relationships, this icicle chart is doing a great job. Just like the sunburst chart, each internal node has its independent space, so the hierarchy is easy to perceive. Since we are dealing with straight lines and angles are not involved, we just need to look above and beyond each node to follow the hierarchy. So I would say the icicle chart is even easier than the sunburst chart to perceive and follow the hierarchy. However, with the icicle chart, we no longer have the advantage that nodes deeper in the hierarchy, such as leaves, get more space than their parents. So, if we start with a not wide enough root, we may end up not being able to detect some leaves, let alone labeling them. And before I forget, among these three, the icicle chart is probably the simplest to understand for somebody with no background in data visualization. On this slide, I am showing all the three visualizations of the employee salary data. Remember that the goal of these visualizations is not to indicate the exact numerical values, but to break the data set into its constituent parts and quickly gain insights from them. Instead of a messy pie chart or a busy bar chart with 26 bars with no organization whatsoever, by using any of these visualizations, we will be able to gain insights about individual employees as well as higher level categories like office location and departments. Note that in these three visualizations, we have an aggregation scheme, meaning the internal nodes are associated with a quantitative value equal to the sum of their children's quantitative values. Also, note that sometimes our data is hierarchical by nature, and sometimes we hierarchize the data in order to have an uncluttered visualization and to be able to see meaningful patterns and insights. In this example, we had the latter case. We abstracted the data through a hierarchical structure, and that allowed us to have a visually appealing and effective visualization of the full data set. Here we are comparing tree maps, sunburst charts, and icicle charts based on different criteria in these two tables. The first table just tells us whether these charts have a characteristic or not, and the second table attempts to compare these three charts against each other. Note that these criteria are not necessarily independent from each other, and take my rankings in the second table with a grain of salt, as some of these comparisons are still open research problems. Without a doubt, tree maps are more space efficient than sunburst charts. Therefore, in a way, tree maps are more scalable. In a tree map, we recursively nest rectangles inside each other, and in theory, we can keep going with nesting rectangles using the same amount of space. In sunburst charts, on the other hand, outer parts tend to get bigger than inner parts, and we can easily run out of space. Also, in icicle charts, for each new layer, we need to add a rectangle at the bottom, and again, we may run out of space. Another way to look at it is to say that tree maps use shared space for different levels, but sunburst and icicle charts assign independent space to each node and each level of the hierarchy. Between sunburst and icicle, it is hard to tell which one is more space efficient. It really depends on the size and the depth of the data set. Labeling for all these charts can become an issue when we have a large data set. Since tree maps are more space efficient and the leaves can become very small, they are the first among the three to become cluttered, followed by icicle charts and sunburst charts. Both sunburst charts and icicle charts are better at visualizing the hierarchy than tree maps. This is because each level of the hierarchy is assigned a separate layer in the sunburst and icicle charts, and hence it is easier to perceive the hierarchy. With tree maps, we can easily lose the categories in the middle of the hierarchy. For the same reason, when the hierarchy is deep and so it has so many levels, we would be better off using a sunburst or icicle chart. In these cases, tree maps would be hard to look at. In terms of visibility in deeper levels, tree maps are the worst, as the rectangles in the lowest level of a deep hierarchy, which represent the leaves, can become very small. But on sunburst charts, outer parts tend to get bigger than inner parts, and so the leaves are going to be more visible. Icicle charts are going to be somewhere in the middle in terms of visibility of deeper levels. In all of these three chart types, we can encode two quantitative variables at the same time using size and color. However, in tree maps, the visualization of two quantitative variables is going to be more effective, and we can find patterns and draw insights more easily. Part-to-whole comparisons are possible on all the three types of chart, but as I explained earlier, tree maps can do a better job than sunburst charts. This is because comparing areas of rectangles and dealing with straight lines is easier than dealing with angular measurements. Tree maps probably do a better job in terms of part-to-whole comparisons than icicle charts as well. None of these charts does a good job in enabling part-to-part comparisons. There is a lack of a common baseline in all of them. Nevertheless, I would say icicle charts would be better than tree maps, and tree maps would be better than sunburst charts. In icicle charts and tree maps, we do not deal with angular measurements, so they are better than sunburst charts. And in icicle charts, we can just focus on the width of each category instead of its area. So icicle charts would be better than tree maps in terms of part-to-part comparisons. Sometimes we have data sets with values close in magnitude. Both sunburst and icicle charts would make great visualizations when we have values close in magnitude. However, tree maps would not be effective in this case, as they would look like a grid. We may even experience some distortion in the form of more patterns. As I mentioned before, the icicle chart is probably the simplest to understand for somebody with no background in data visualization. Next would be sunburst visualizations, and the hardest one to understand for a layperson is the tree map. In year 2000, a pilot study out of Georgia Tech investigated the effectiveness of sunburst charts and tree maps. The study was actually done by John Stasko, the inventor of sunburst charts. The conclusion was that there was no significant differences in task completion times of participants between sunburst charts and tree maps. However, the participants strongly preferred the sunburst chart. One can argue that the tree maps that Stasko used were not the best tree maps generated by the most effective tiling algorithms to produce nested rectangles. So perhaps that would have been the reason for the participants to strongly prefer the sunburst charts. Several other pilot studies were done comparing these charts when performing different tasks such as search tasks and analysis tasks. In year 2020, a project out of Newcastle University in the UK investigated the effectiveness of 5 charts including tree maps, sunburst charts, and icicle charts. In year 2020, a project out of Newcastle University in the UK investigated the effectiveness of 5 charts including tree maps, sunburst charts, and icicle charts. They found that for large hierarchies, sunburst charts perform better than icicle charts and tree maps. Furthermore, they found that for small hierarchies, tree maps and icicle charts outperform sunburst charts. So, there is no concrete answer to this research question. In general, more studies favor sunburst charts with respect to performance in completion of a task, particularly if the participants have never used these hierarchical visualizations before. They tend to be more comfortable using the sunburst and icicle charts than using the tree maps. Based on the characteristics of our hierarchical data and based on what we want to achieve from visualizing the data, there are some guidelines for choosing between tree maps, sunburst charts, and icicle charts. If this space is limited and we want the visualization to be compact, tree maps will be our best choice. Tree maps compress a lot of data in a small space and convey high-level insights efficiently. If we have two quantitative values for each category, we should go with a tree map. In case we have a small number of categories and we want to compare parts to whole, the best option will be tree maps. If our goal is to identify patterns or outliers, tree maps will be more effective. In particular, if we have two quantitative variables to visualize, we can detect interesting patterns on tree maps. If the hierarchy is deep, sunburst or icicle charts will be more effective, since tree maps become visually overwhelming for deep hierarchies. Of course, we can have a long discussion on how deep is considered deep. If the quantitative values that we want to visualize are close in magnitude, sunburst or icicle charts will be a better choice. Tree maps in this case will look like a grid. If our goal is that audience easily perceive the hierarchy, we need to go either with a sunburst chart or an icicle chart. We do not want the audience to lose the categories in the middle of the hierarchy, which typically happens when we use tree maps. If we want the leaves to be visible and they matter to us a lot, we need to go with a sunburst chart. For a small data set, it may not make a difference, but for a large data set, only sunburst charts can represent the leaves in a visible way. Now, let's say our data is flat, having no hierarchy, but we still want to use tree maps, sunburst charts, or icicle charts to visualize this data. Let's say we just have one column of quantitative values. Among these three, tree maps will be the most popular choice, especially if we have quite a few categories. Tree maps are visually appealing, and in case we later want to add a second quantitative variable, tree maps can easily accommodate that by adding color as their second data channel to represent quantitative values. A sunburst chart with non-hierarchical data will effectively be a donut chart. As we know, pie and donut charts with quite a few slices have significant problems. And finally, icicle charts with non-hierarchical data will be like a stacked bar chart. If our goal is to compare parts to parts, these stacked bar charts can do a better job than tree maps and sunburst charts. To summarize this lecture, tree maps, sunburst charts, and icicle charts are useful for visualizing hierarchical quantitative data with a tree layout, meaning a root, branches, nodes, and leaves. Tree maps, sunburst charts, and icicle charts should not be used to draw accurate comparisons. Tree maps are compact, hence space efficient and scalable, but it is hard to perceive and interpret the hierarchy from them. And sunburst and icicle charts are less space efficient, but when we use them, the hierarchical structure is easier to perceive. Alright, good enough on visualizing hierarchical quantitative data. Thank you.